Okay, so we're gonna solve this problem. So the function y1 of x equals x squared is a solution of this equation. Okay, but notice that this equation is kind of difficult because this equation has variable coefficients here. Okay, so we are gonna be able to use quadratic formula, but for not this kind of problem. We will be able to use quadratic formula when these coefficients are constant, not variable. Okay, so this is harder than we can do usually. So that's why this is a good test for this method. So if somehow you can guess one solution, then you can find a second solution, and because this is second order, you can find the general solution. So a general solution, so let's say solution, a general solution will look will look like y of x equals c1 y1 of x plus c2 y2 of x. Okay, because it's linear. This equation is linear. Okay, so we already know y1 of x, so we know y1 of x equals x squared, no? Over here, y1 of x is x squared. So to find the second solution, we need to use this formula. Sorry, let me put it here. Where did I put it? Here. So if you have this equation, then your formula looks this. That's the formula you want to use. Okay. So let's write that equation down. So this equation looks like the equation is second y prime plus p of x y prime plus q of x y equals to 0. Okay, so the formula says y2 of x equals y1 of x integral, then you have y1 square of x dx, and then e to the what? With minus, right? Minus p of x dx. Okay, so let's double check just to make sure. This is, yeah, minus integral px, right? Okay, so here we go. So sorry, I hope I'm not making you dizzy. This. Okay, so the equation we have, it doesn't really look exactly like this one. Okay, because the equation we have has x squared on at the beginning, and this one doesn't have x squared at the beginning. So we need to change this equation. So we need to change it to, we need to divide by x squared. So we got y second prime minus 3x over x squared y prime plus 4y 4 over x squared y equals to 0. Okay, so we get second y prime minus 3x y prime plus 4 over x squared y equals to 0. Okay, so now this one look more like what we wanted, right? So this one look better because now it looks more like this. So now we can ask what is p of x? So p of x is, sorry, draw. P of x is negative 3 over x, right? change it to this one. P of x is negative 3x. So we need to make that integral. So y2 of x is going to be equals to y1 of x, that is x squared, times e to the minus integral of p of x. So that's this one, right? Minus 3 over x dx, here dx, over y1 squared. So what is that? So x to the 4, right? X to the 4. So we need to find this integral. So we get y2 of x equals x squared. And then minus 10 minus is plus, right? So what is the antiderivative of that integral of minus 3x? So we get e to the minus 10 minus plus, let's say, okay? So we got 3 ln of x, right? So we got x to the 4 dx. And now we can take care of this 3 in front because we don't like that 3 in front. So we're going to put it up, right? So we get y2 of x equals x squared integral e to the ln of x cubed x to the 4 dx. So this e and ln cancel each other, right? And then you see this is interesting because, well, okay, you can leave this, s cube, but in this case, you see dx is between 0 and infinity. So because x is between 0 and infinity, I'm supposed to have absolute value, right? But since it's between 0 and infinity, so the absolute value is not need, okay? Otherwise, I will have to leave it there. So make the problem harder. So because x belongs to 0 infinity, I forget about the absolute value. I can put the 3 up and then this cancel. So I got y of 2x equals x squared s cubed over x to the 4 dx. And this is y2 of x equals s squared. And this cancel, right? So there will be integral of 1 over x dx. So it's y2 of x equals x2 times ln of x. Okay. So my general solution will look like general solution, as I said here on the top, is this one, right? C1 y1 of x plus C2 y2 of x. So y of x equals C1, y1 of x is x2 plus C2 s squared ln of x. And that's my general solution. Okay. And then we'll start building from there. Okay. So that's how do you solve that equation.